Ever had trouble controlling the direction and position of your crowd agents in your simulations? Crowds move agents as if they were particles, and it doesn't really understand complex motions that need to stay in place and pause before moving around in the world. In this video, I'll demonstrate how to configure the pivot or origin point of the agent while telling Houdini how to interpret your complex animation motions in crowds. Basic concept number 5, in-place and locomotive animations. And then let's play it. Now you'll get to see the animation play in the viewport. And you might be thinking it's working. Well, not exactly. This animation that we've attached to our character agent is actually moving in world space, physically jumping forward in the world space. It's not jumping in place, which is something I've mentioned in the previous basic concept. That means we need a little bit more information. We have to actually tell Houdini that it's actually moving in world space. We want the crowd solver to know about it. Now, if you look carefully in the viewport, I'm just going to rewind this. I'm going to play for just a bit. Now, as the character is jumping forward, I want you to see this circle is over here. Sort of indicates the origin position or the pivot position of the character agent, which is essential. This is where Houdini thinks the character agent is actually positioned at. But in reality, you can see that our character is moving forward. Our character is jumping this way. So it's actually moved away from the circle. So that's not very good. Later on, you're going to see the crowd simulation will not understand this character animation data properly, and it's going to give you chaotic results. We need this little circle to sort of mark where the character is jumping, so it pivots correctly, or the origin point. It actually updates the origin point. We need to create the locomotion joint, or more as you need to enable convert in place animation. Check this, and it gives you an error right away. So let's see what this error is. It's saying joint does not exist. That's because our locomotion node, these two parameters over here, they're empty. So it doesn't know what to do. That needs the pivot point in your character rig. In the previous basic concept, I briefly talked about the control bone, which is a bone that is the parent of all the bones in the character rig. If you move the control bone, or it may be called the root bone or main bone, there are many different names for it. If you move this control bone, the entire character rig will move with it. This is what the locomotion needs. It needs one bone to mark the actual position, the origin position of the character. For this, I called it the control bone just because that's what I named it. Now, you will have this locomotion bone available for selection. This is an extra bone that Houdini creates automatically when you have this option enabled, when you have the create locomotion joint enabled. I don't use this just because I already have a control bone. You can try to use this. It doesn't always give you the best result. And the orient, I would put the control. So this helps Houdini figure out the orientation of the character. For this particular example, it's not going to make much of a difference just because the character is going to be staying in an upright position, just jumping up and down. So we're not going to see much difference between this, but the locomotion will be more important. Now let's see what we have. So the character is just jumping in place, which is not very helpful. So you also have to enable this apply clip locomotion. So we not only do we have to tell Houdini about the control bone, and we have to tell Houdini to convert it to the in-place animation, which is this guy over here. We also have to apply all this stuff to the character agent. So once you enable this, and then we play again, you'll see that the animation, it's jumping in world space. And one more important thing to notice is that the circle is following the character. So the character is no longer flying off without the circle. It's always there with it. So we can play this, see that the origin, which the circle is sort of signifying indicating the origin position of the character. So it's very important that it follows it as well. All the options in this clip preview section over here is only for previewing in the viewport. So we'll know what's going on while we adjust the agent clip node. It doesn't affect anything that happens in the crowd.net simulation. But when we enable the apply clip locomotion option, I find that it affects the previews for other animations that we attach later on as a chain, which I'll show you in the next video. I want to focus on just setting up the animation for the agent first. Just remember, if you chain a few animations to your crowd agent, like having the jump, run, walk, and different types of animations attached, and you start to experience chaotic results in the preview, remember to come back to this option and try disabling the apply clip locomotion option to see if that helps. Again, this clip preview section should only affect the previewing. So the agent clip is not only important for attaching motion clips, animation data to the agent, it's also important to fix or configure the origin position. Now what I want to try and do is disable the convert in place animation. Let's see what happens, and then let's play it. Now, this is what I wanted to show you. You can see the circle is actually moving. So let me play back a bit. And I want you to keep your eye on this circle over here. And I'm going to play it forward, and you can see the circle is doing something. It's not correct just because one, it's not following the character correctly, but it is trying to, like, it's not keeping up. That's what this option is. It fixes the origin position of the character agent. So once we have, let's enable it back, and you'll see that the character and the origin, that little circle, is following our character agent properly. So that's something that you need to know, or it's nice to know. That's basically all you need to do to attach an animation to a character. So let me put down a null, and I'm going to call this out agent. So I can find this node later on. Now, if you want to attach multiple clips or multiple animation clips to it, you can just throw down another agent clip node, and it'll work like a chain. And you'll have another animation data over here. It could be running animation. I don't actually have one available at the moment. So, but if you did, you would have the same setup. You would have the same animation setup, and all this would go into the clip node, just like how we set up at the top. So this would go in here, and then you can set up the agent clip the exact same way. Now, I don't actually have anything available, so I'm just going to remove that. I'm going to move this down so it's a little more organized. What I really want to show you is you may not always have animation data coming in with displacement, like having a character actually jumping in real time. Some of your animation data may come in as jumping in place by default, and I'll show you that by importing a second version of the same jumping animation, but it's jumping in place. Let's play it. So the character is actually jumping on the spot. He's not moving much. He's not moving at all. This animation data is a little different. If you have this jumping in position, you don't actually need the convert in place animation enabled, and you don't even need the locomotion setting. Like, you don't need a lot of stuff. So let's just try to disable this, and you can see that this grays out as well. Let's play the animation. So it still works properly. Just because it's jumping in place, the origin position is not changing. It's always in the center. What you do need is this stuff up here. If you want to preview the clip, you need to set the clip to the jump, and you have to apply the clip locomotion. Like, you may not even need this, but you have to apply the clip time to actually play it forward. So jumping in place is a lot easier. The next thing you might ask, why have animation jumping forward? Why don't you just have all the animations jump in place? Because the setup is a lot simpler, right? There is a downside to this. The original animation data does not tell you when this character is actually jumping and pausing. So it's not always moving forward, and that's what the crowd simulation will do. It's always going to pretend it's going to move forward, and you're going to see foot sliding. And I'm going to show you that in just a second. So I'm going to leave this as and set up the crowd simulation to show you the foot sliding, and then we're going to change it back to the previous version where it's jumping in world space. And then you can tell the difference. Okay, let's go back up. So this is going to be the agent. Now let's drop down another geometry node. I'm gonna remove the render flag off the agents because we don't really want to see that. We're gonna be importing the agent into the crowd simulation anyways. So let's go into that. Let's drop down a crowd source node. Now we have our default geometries, which is not what we want. We need to bring the agent that we had set up in the other geometry context and bring it in here and hook it up to the first input. We can do that by just simply dropping down object merge. We'll import the agent data into this contact. Drop this down and I'm just gonna find it. That was called agent, out agent. That's what we called it. So take that and you'll see it appear in our viewport. So we play it. Because the agent clip was already set to the jumping, it's going to be jumping in place, which is fine. Now we're going to hook this up into the agent input. Put the render flag onto the crowd source and let's just play it. They're all going to be jumping in place because that's what all the agents were set as default when we did this, when we were over here. In this agent clip node, we had set the clip to jump over here. So they're going to be stuck. It actually remembers that set. So if you have, here I only have one animation, but if there was another animation like a walk and run, and this was set to run instead of the jump, it will be stuck on the walk and run, jump, or whatever you last set the motion clip to. So I don't really need that many of these guys. In fact, I just want 2 of them. What I'm going to do is drop down and add because I want a dot. Crowd agents are just point. They're going to be represented in points in the crowd solver. So I'm just going to put 1 dot here. Well, actually, I want another one. So I want 2. The second one over here, I'm going to move it a little to the right. Now I'm going to take this and put it into the second input of the crowd solver. Now let's put the render flag here, and we only have 2 of these. Now they're a little close, so I'm just going to move it over a bit more. Now they're doing the same animation. Now if you wanted another one, you can drop down another one. You can drop it here. So I just wanted to show you how you can control the actual, how many agents, exactly where you want the agent to be using points and using the second input of the crowd source. Another way you could do this is using the scatter node. If you can drop down a grid and scatter a bunch of points, or maybe you would want to reuse these points on the grid. So what I would do is drop it in add, and I'm going to remove all the geometry but keep all the points. So there's this option in the add node where you can delete the geometry but keep the points, and that's exactly what I want. This could come in handy if you want your agents in a grid-like positioning alignment. So let's see what this goes, and we have now an army of jumping agents. So this could be something handy if you're doing like a stadium and they're doing that big wave, and this could be how you want to position them. You can manipulate the grid though. It doesn't have to be exactly like this. So you can go like, and I'm gonna change the grid. Select the point. Change this, press T, and I'm just going to move this over manually. And let's see what we get. Let's put the render flag on the crowd source. So you can see that the agent positioning is reflected, or it's updated. Where the points are, the agent will be at. That's the positioning. Now we're not going to do anything that complicated, so I'm just going to get rid of this. I'm just going to have a simple add. In fact, I only want 1. I don't actually need the other one. So let's remove this. Now let's set up our crowd simulation. Let's put down a .NET. Let's hook up this crowd source to the first input of the .NET. Like any good crowd simulation, we need a crowd object. So let's drop down a crowd object. We need a crowd solver. This one. And let's hook this up. So as I've shown in the previous basic concept, crowd object goes to the first input of the crowd solver, and this goes to the output. But we also have to tell Houdini where to find the agent. In the crowd object, crowd tab, initial geometry. Now that's where we're going. I actually hooked it up to the first input, so we can just use the first context geometry. So that'll bring it in. Now it's not looking correct, is it? As I mentioned in the previous basic concept again, I know I keep going back to that. We're missing a crowd state, and once it's missing the crowd state, it's not importing the geometry correctly without the crowd state. So we at least need a valid crowd state. So let's drop that in, and it's called jump. We called it jump. And let's hook this up to the third input, which is for the states. Instantly we get it in the right size and the right positioning. Play it. It's jumping in place. Now this is the foot sliding that I want you to notice. Here. Slide, jump, slide, jump, slide. This is because Houdini has no idea when to pause this motion. Houdini treats the crowd agents like it's particles. You give it a heading, a direction to head towards, and you give it a velocity. It'll move it like a particle. It doesn't know, okay, the jump requires the character to stay in place when it lands. Like here, you would pause, and then you would move it forward and pause. Like it doesn't know about that. You actually need that data in the raw motion. And that's where we go back to what we had before. That the other version of my jumping motion. So let's go back up. And let's go back to the agent node. Now we're back here. And let's load back the previous animation. The jump that is jumping forward. So it actually has that data where it pauses. Otherwise Houdini won't know. So let's import that. I call it jump with displacement because it's being displaced in the world scene. So let's take a look at this. This is actually jumping forward. What I want you to notice closely is that jumping has a pause as well. Okay, let's forward. Jump, it stops. It's pausing. Now, this is the jumping motion data, the raw motion data. That's the information we need to tell Houdini. We need to tell Houdini, take into consideration the jumping motion is not always constant. That's what we have to relay the information to Houdini. And I'm just going to put the render flag on the agent clip node just for a second. And notice that once we switch the animation data back, notice our origin point. It's not aligned with our character. Our character is over here. So it's not aligned. So we have to enable the locomotion settings. We have to create that locomotion joint so it knows, so Houdini will know which bone to actually track down to align with. This is the origin position of the character. In my case, I call it the control bone. Again, it could be like the root bone, it could be the hip, it could be anything. So we have to enable this in order for Houdini to know what it is. Like we have to tell it what it is. Let's play it again. It going in place. Not very helpful, right? We're missing that one, this option over here. Apply clip locomotion. So we actually have to apply it as well. So click that. Now we can play it and you'll see that the origin point is aligned with the character. So that little circle underneath it, it's following that character. Perfect. Now let's go back to our crowd simulation now that we have more accurate jumping data. So in the crowd simulation, let's go into the .NET. Now let's play it. It's not updating, right? One more option we need to set in the crowd state. So in the crowd state over here, clip playback. It's asking us for a type. Now, there's actually two types, in place or locomotive. In place means that the crowd solver will completely take over where the crowd agent will move to. How fast it moves, where it moves, it will completely control over that. Now, we don't want that. Just because our motion, our animation data already has some of that data in there. We have to tell Houdini, don't control everything. Take into consideration that the jump is actually pausing in the middle in between jumps when the character lands. That's where comes in handy. You have to switch it over to locomotive. This tells the crowd solver to use the animation data with the offset. So once we switch that over, let's play it again. And no more foot sliding. So this is something I want you to see. Let me rewind. So this is what I want you to see. It jumps, it stays in position. So let me... Okay, let's take a look. It jumps, it jumps, it jumps. Now this is more realistic. It has a jumping motion. Pauses, and you can see that little circle is following it correctly too. It's not going on its own little world. So that's what this locomotive type is. That's what it means. So your next question might be, why do you have to set it in twice? It's not really setting it twice. This locomotive option sort of tells the crowd solver what to do. Should I follow the animation data or have me take over everything? opposed to the agent in the agent clip node. These locomotive settings are a little different. This actually sets or fixes the origin position, that little circle. So this is setting the origin position of the character animation. Both of them have to be set correctly in order to get the predictable result that you want. Otherwise, if you don't have it set up correctly, you'll have unpredictable results. Thanks for watching and sticking to the end.